My name is Douglas Cook. I'm your instructor for Auto 203 manual transmissions. In this video today, we're going to be going over the automotive clutch system and the components that make up that system and how they are constructed and how they work together to do what we need them to do. So let's start off with what exactly do we need them to do and why? An automotive clutch is a system that is between the engine and the transmission, and it acts as a coupler and a decoupler so that we can have the engine spinning and generating power and transferring that power from the engine to the transmission through an input shaft. But there's times when we need to be able to disrupt that power flow. And when we need to do that is when we are coming to a stop and the engine and the wheels are actually going to stop turning, or if we need to shift gears in a manual transmission. And the reason that is because we want our engine to be able to keep turning and operating even though the wheels are not turning. And if we can't disconnect the wheels from the engine, then every time we came to a stoplight or came to a stop, the engine would stall and die on us. And we don't want that. So we have the clutch system. So first off, let's look at the first component we come across is a flywheel. Let me do it. Start at the second camera here so you can see. And here we have a flywheel. You'll notice it's a pretty big, substantial component. This one is actually kind of small as far as flywheels goes. It was probably off a 4-cylinder or a small economy car. But still, it's quite heavy. It's a large chunk of metal here. We have the different pieces that make up the flywheel. We have the center section, the large metallic. The bulk of the flywheel is just a large chunk of steel. You see on one side here, we have a smooth machine surface. I'll let that camera focus a little better. There we go. So we have this nice smooth machine surface here. And then we have this outer ring here. And then you see in the center, we have several holes here directly in the center of the flywheel. And what the purpose of this flywheel is to do several things for us. One of the things it does is it helps absorb engine pulsations. When an engine is running, the different cylinders are firing at different times, and this will cause a natural pulsation of energy transferred through the crankshaft. Each time one of those pistons goes down on a power stroke, it can be felt in the crank as a pulsation. Well, for driving comfort, we don't want to be able to feel those pulsations and the starting and stopping of the engine power. So to help avoid those pulsations being felt or perceived by the driver, we can have something like this flywheel, a big, large, heavy weight that helps absorb those pulsations. The weight of the flywheel will continue to keep the crankshaft moving. The inertia of the flywheel spinning can help balance out some of those pulsations. So that's the reason they're such a large, heavy component, is they're helping us smooth out the engine power delivery. The second job that it's going to do for us is it gives us this nice flat machine surface for the clutch to ride on. Once we get to the clutch disc, I'll show you how it sits in here. But we need to have a nice flat, smooth surface to have the clutch disc clamped on. If this surface wasn't completely smooth, then our clutch application would be jerky and it would jolt and we'd have chattering and all kinds of different complaints. So it's essential that this surface be smooth, completely smooth and machined. So the third function of our flywheel for us is, you can see here on the outside edge, we have all these teeth. Let me turn it over. You see these teeth on this different colored metal here on the outside edge of this flywheel. This is a ring gear that we use to engage our starter. So anytime you hit the starter and you want to crank your engine over and get it fired up, your starter gear engages with the teeth here on the ring gear of our flywheel. And it's what is going to spin up the flywheel and get our engine turning for us. So this outer ring, you notice it's a different material than the rest of the flywheel. This is a hardened steel that has been press fit on the outside edge of this flywheel. So this is two separate components that are press fit together. So something else you'll notice here, we have some partial holes drilled over here on this side of the flywheel. This is because the flywheel needs to be completely balanced. It's spinning as fast as the engine, as high as maybe 6,000 to 7,000 RPMs. So it's essential that this heavy mass of metal is balanced. Otherwise, the engine would get thrown off balance and we'd feel all kinds of vibration and harshness coming from the engine. So these are places where when they spun this up to balance the flywheel, they had to remove some weight to help balance this out. So you may notice holes like this partially drilled. Some flywheels you may actually notice they have weights that may be welded to the structure itself to help balance it out. But so let's move it back over. So let's get back to these holes here that we have here. This is where it's going to bolt to the crankshaft, the rear of the crankshaft at the engine. So we're going to have these bolts. They're going to be torqued pretty hard because we're connecting this heavy flywheel, the mass here, to the back of the crankshaft. If any of these bolts were loose or not tightened properly, again, you're going to have all kinds of vibration and roughness coming from the engine and the transmission. So this is our flywheel. Next component we have is our clutch disc. And clutch discs are the actual friction material that we're using to clamp and pinch against this surface here. So a clutch disc, the purpose of the clutch disc is to give us this friction material, this grippy material that's actually going to allow us to pinch and hold, clamp and hold this clutch disc in between the flywheel and the pressure plate, which we'll get to next, and transmit the engine's energy and the movement of this flywheel to the input shaft of the transmission. And the way we do that is this clutch disc is going to be clamped between the flywheel and the pressure plate. And so when it spins, you can see here in the center, we have these splines. This center hub of this clutch is going to be splined to the input shaft of the transmission. So it's going to transmit the rotational force of the crankshaft to the input shaft of the transmission so that we can run it through the gears and out the back. So we have to this is the part that we have to be able to clamp and release so that we can connect the engine to the transmission and let it go. And you'll notice here also we have some springs. These springs help absorb some of that rotational energy when we apply the clutch and we release it. When you get ready to clamp that clutch, and that clutch goes from not spinning, maybe not much at all, to engine speed, it can be an abrupt grab. It can kind of be a jolt on the system. Well, these torsional springs here help absorb some of that force. So when we apply the clutch, these springs can kind of give it a little bit of a cushion to help absorb that abruptness. So also to help with some of that abruptness, you may notice, if I point out here, is we have between these two friction material sides, there is actually, you can kind of see in there, a little wave spring. And what that is a piece of metal that has a wave in it. And so when we get ready to clamp this clutch, it actually acts as a spring to kind of soften the application of the pressure plate and the clutch disc. It helps, again, smooth out the transition from being decoupled to coupling the clutch. All right, let's go to the next component. So now we have our flywheel, our clutch disc, and now we need something to generate the pressure to clamp this clutch disc to the flywheel. And that is our pressure plate. You see here, it sits on the back of the flywheel like that. You can still see the splines for the clutch here in the middle. And you'll notice all these the fingers here. So what these fingers actually are is a diaphragm spring. And you'll notice that there's a bunch of little fingers going in here. Well, all these are connected to a ring in here. It's all one piece. And what it is it's a spring, kind of like a disc like this. And when those fingers are up like that, the outside is pressing down. So that outside is pressing down against this metal plate here on this side, which you notice again is a completely smooth machine surface to give us that nice smooth application of clamping force to the clutch. And so these fingers are pressing against this plate here. And so that is what is actually clamping down on our clutch disc. And so this is where we get the clamping and the release that we need to be able to couple and decouple our engine and transmission. When we push down on all of these fingers here, they're in the middle of this big diaphragm spring. When we push down on them, the outside of the pressure plate is pulled up. So that's where we get the clamp and the release of our clutch. So our pressure plate is what is applying that pressure and holding that clutch to the flywheel. If this pressure plate for some reason couldn't generate enough force to clamp that clutch, then we get what's called slippage, and the clutch would just be able to spin freely in there. So these springs, this diaphragm spring has to be really strong. This is one type of pressure plate. Another type of pressure plate, instead of using this diaphragm spring with all these fingers, will actually use a normal coil spring, a series of coil springs around the outside, and there's going to be levers that come to the middle, and there's going to be a lever for each spring. And just like we press down on these fingers to release this clutch, this spring, in a coil spring, it's going to be the same thing. When we push down in the middle with our throwout bearing, which we'll get to next, it will release the pressure on those coil springs. So you can have different designs for your pressure plate. I'll say the diaphragm spring design is probably the most common, but you can have a coil spring application. So then let's get to that throwout bearing. So this pressure plate, clutch, and flywheel assembly are spinning with the engine at engine speed. But still, we need to be able to push on the center of these fingers to release that clamping pressure. Now, to do that, we're going to need something that can press against these fingers, but also spin up the speed with the engine. And that's what the throwout bearing does for us. If you look here, this would be mounted in the bell housing in between the engine and the transmission. This silver metal part here would be the front cover of the transmission. And then this piece here is our shift fork, our clutch fork. Sorry, not shift fork, clutch fork. This is our clutch fork. And you notice when I push on the clutch fork, it pivots here in the middle. And it pushes this assembly forward. And this piece here, you know, is a bearing. This center piece can spin. This is our throwout bearing. And this is our clutch fork here. So when you push on the clutch pedal, what you're doing is actuating this pivot here and causing the throwout bearing to push forward. And what that does is the throwout bearing will then now press against those fingers of that diaphragm spring or the levers to release the coil springs and actually release the clamping force from this plate here, this pressure plate. So when you engage the clutch with your foot, this is what you're pressing. This is the movement that you're getting transferred from your pedal down to the transmission and engine area of your car. So we have our throwout bearing, which allows the pressure plate to be spinning, but still apply pressure on these fingers to release the spring. So there's a couple different designs for a throwout bearing actuation. This one is a clutch fork. You see we have a pivot, and you're going to have something either push or pull on this end of the clutch fork to apply the pressure with the throwout bearing. Another design is a collar style where you don't have this clutch fork. There won't be a clutch fork in a collar style throwout bearing. What you'll have is the slave cylinder, which we'll get to, which is a device that would sit back here behind the throwout bearing. And anytime you push the pedal, it would push forward on the throwout bearing. So there would be no need for this clutch fork, because it would be, the assembly would be here behind the throwout bearing, in between the transmission housing and the throwout bearing. That would be a collar style throwout bearing. So we have this throwout bearing that we need to be able to push forward, and we push the pedal with our foot to actuate the clutch. Well, we need to be able to transfer that movement from our foot pushing the pedal down to the transmission to apply this clutch fork. There's a few different ways we can do that. The most popular, I think, is a hydraulic style clutch actuation. And what that is, it's similar to our brake system in our car. There's going to be a hydraulic fluid in a sealed system, and when you press the pedal, you actuate a rod that is exerting a force on that fluid. And because it's in that sealed system, that pressure is transferred through the system down a series of lines and lines that could either be steel tubing or a rubber hose down to a slave cylinder. And a slave cylinder is just a small hydraulic unit that when pressure is applied to one side, it actuates a rod. Or if you have a collar style throwout bearing, it would actuate a collar that would actually push forward on the throwout bearing. And that slave cylinder just has a rod and a sealed chamber in it. And the hydraulic pressure generated at the master cylinder with your pedal is transferred down through to the slave cylinder, which then actuates a rod that pushes on our clutch fork. That's probably the most popular or most common style you'll see. Some smaller cars, you'll see these other styles, and older cars, you'll see have some of these other styles. The next style we're going to talk about is a linkage. And in a linkage setup, there would be no hydraulic fluid. It's all going to be a series of rods and pivots and levers and hinges, and the movement of the pedal is going to be transferred through this linkage, the sets of rods and whatnot, down to the clutch fork, and it'll actually physically pull or push the clutch fork with a hard linkage, kind of similar to a throttle linkage on an older car also. These linkages aren't that popular because they tend to bind and wear They require adjustments and a lot of maintenance. So clutch linkages have kind of stopped being used. The third style you may see, and it still is common today, probably not as common as a hydraulic clutch actuation, but you have cable actuation. And that's instead of a hydraulic system or a set of linkage going down to the clutch fork, you just have a cable, similar to the brake cable on a bicycle. When you push the pedal, it'd be the same as pulling the lever on a brake cable. And that movement is transferred to the cable that would then be attached to the end of the clutch fork. And so when you push the pedal, it would actuate the clutch fork and release the clutch forks. So those are 3 styles of clutch applications that you'll see on some cars now. Modern cars, clutch actuation is automated. So you actually may have a electronic solenoid that is going to apply the clutch for you. That's not too common yet, but still you may see it on some higher end sports cars. So the last thing we need to talk about is our pilot bearing. If we have the input shaft of the transmission coming out, and we have our clutch disc splined to that input shaft, and we need to be able to turn this shaft when the clutch is clamped by the pressure plate against the flywheel. Well, this input shaft is going to be under a lot of stress and load. So we need to be able to support the input shaft of the transmission at the front. And that's what the pilot bearing does. So in the center of our crankshaft, in here in the middle of all these holes, there would be a pilot bearing pressed into the back of the crankshaft. And the input shaft of the transmission is going to fit snug inside of that pilot bearing. And that bearing is going to allow the input shaft of the transmission to spin independently of the crankshaft. This pilot bearing will also support any kind of force that may be exerted on the input shaft of the transmission and just help keep everything nice and secure and a pretty solid unit. Now, the pilot bearing can have a couple different designs. It can be an actual needle bearing style pilot bearing where you have little needles in there and you have your inner and outer race on the bearing, and the input shaft is pressed into that inner race. That's the needle bearing style pilot shaft. Or you can have the bushing style where there is no needle bearings. There actually is no bearings. It's more of a brass bushing, similar to what you may have in an engine bearing, or in a rod bearing, or a main bearing. And it's just a softer material that allows the input shaft of the transmission to spin inside that, inside the center of that recess in the crankshaft. So hopefully, or that's all the components that we have here to talk about. In the next few videos, we'll be going into more depth on how they work, diagnosis, maintenance, and repair. But for now, this is just the overview of the components and their construction and how they work together. So thank you, and hope you have a good one.